All right, so today we're talking about standard deviation and variance, these are both measures of spread, so that's important to note. Measures of spread. And just to recap, the other two measures of spread, so how spread out our data is we have the range and that inner quartile range called IQR, inner quartile range, like the box in our box and whisker plot, if you remember that, right? Our box and the box and whisker plot, this is the IQR, and that has 50% of our data, right? It's in that inner quartile range. The range is just from the maximum to the minimum, and these, though, kind of give us more of an idea where the bulk of our data is, not necessarily just the middle 50%. So standard deviation is how spread out our numbers are. We have a symbol for that, which is lowercase sigma. Looks like this, and if you're drawing it, it's kind of just like a little circly O. Okay, and sigma, standard deviation, is the square root of the variance. Okay, and the variance is another way of calculating how spread out our numbers are. And it is the average of the squared differences from the mean. So don't worry about that definition too much. It does use this crazy formula down here as well, but we're actually going to do that in parts, kind of follow these steps. Okay, for now, the important part, though, is standard deviation gives us an idea. If we have data that's somewhat normally distributed, so if you kind of look at this chart, this is called a bell chart. So we have kind of evenly distributed data. When we do this standard deviation, when you are one standard deviation from the mean, like above and below, and this middle line would be like the mean or the average. If you're within one standard deviation, that is 66 or 68.2, roughly 68 in this rule down here. 68% of our data is within one standard deviation from the mean. If you go all the way out to 2 standard deviations, so all the way from one side to the other, this contains, as you can tell down here, 95% of our data is within 2 standard deviations. And if you go all the way out to 3 standard deviations, that's 99.7% of your data. Okay. We also can use this to kind of identify when we might have outliers, etc. as well. We won't go too in depth with that this year. So we're going to use this formula really quick to answer our first 2 questions here. Find the variance if the standard deviation is 4. So using this formula up top, we know that the standard deviation is equal to the square root of the variance. And it says find the variance. So variance is what we're solving for. Let's just plug in an x there. If our standard deviation is 4. So what number would they had to have taken the square root of to get 4? So you might be able to figure that out in your head, or of course math-wise. To get rid of that square root, we can square both sides of our equation, and we end up with 16 is our variance. Okay, pretty similar. We're going to use the same equation, that standard deviation is equal to the square root of the variance. And this time, find the standard deviation. So let's call this side x if the variance is 70. So all we're going to do is take the square root of 70. So using some Desmos here, square root of 70 is about 8.3666. We'll say about 8.4. So x, our standard deviation, is about, oops, some pen problems here, is about 8.4. Okay, so there's our standard deviation. Okay, so to calculate standard deviation, we need to first find the variance and then take its square root. So we're going to do that. We're going to go through these steps, which is this crazy looking formula here. And let's go through our first example. Hopefully this will clear some stuff up for us. So problem 1 says junior high basketball team played 10 games. Find the variance and standard deviation for the number of baskets scored by the team for these 10 games. Well, they're not very good because these are all single digits. So hope they learn how to shoot a little better. You normally don't need to put these in order, but since these are, I see some repeated values, that's going to save us some time doing some calculations here. So let's put these in order. So for instance, I have 4. I see another 4. We got 1 5. We have 2 6s. So we're adding these in our data column here. 2 7s. 2 8s. And a 9. Okay, so the next thing we need to do is we need to calculate the mean, which is the average. Right? So to find the average of all these numbers, we're going to need to add them all up and divide by how many there are. So let's do that quickly. Okay, adding them all up, we get 64. And then there are 10 pieces of data if you count these out. So we're going to divide 64 by 10. And that should give us 6.4. Yep. All right, so our mean is 64. Or sorry, 6.4. And so we can plug that in all the way down here, 6.4 for all of these. Okay, so we can fill all those in. Once we have these all in, the next thing we're going to do is we need to find the difference between each data point and the mean. In other words, we're literally going to do this operation, the data minus the mean. And we're going to put that answer over here where it says difference. So we're just doing this subtraction. Okay, so when we do this, we're going to want to square. Once we get the difference by subtracting these, we're going to square that number. So whatever answer we get here, we're going to take it and square it and put our answer in the next column. Okay, so that's what we're going to do for each of these data items. So let me do some of these. Okay, so for our first one here, 4 minus 6.4, and hit enter. Okay, there's our answer. And I'm going to tell it to take the answer. Your normal calculators, you can just tell it to square. You just press the square key next. And we want to take our answer and square it. We see we get 5.76. So negative 2.4, and then 5.76. Okay, so find the difference and then square it, and do that for each data piece. Now, luckily, some of these are repeats. Like you notice our next one, if the data is 4, it's going to have the same difference and the same squared difference. Okay, so let's do this for all these pieces of data. I'm just going to fast forward and do that. All right. And remember, you can just pause the video as necessary to copy these down. But we did the difference from all of these, and then we took this value and squared it in our calculator, times itself twice. And the difference squared should always be positive, right? Whether we have a negative item to start or a positive, when we square it, times itself twice, we should always get a positive result here. So these squared differences, all these things we just calculated over here, this is what's going to help us. Can't circle them very well. We need to find the average of these numbers. Okay, and the average of these numbers is the variance. So how do we find the average of these 10 things? Well, we're going to need to find the sum, right? Add them all up and divide by the count. And in this case, there are 10 items, so we're going to divide our answer by 10. So let me add all these decimals up here in Desmos. All right, so adding them all up, there's all 10 numbers are in here. You add all of these up, we get 26.4. Let me mark that in here, 26.4. And then we're going to want to take our answer and divide it. Oops, go back here, I guess. Enter, give me the answer. Take our answer and divide it by 10. I don't know, it doesn't like what I'm doing, I guess. Ooh, okay, really doesn't like it. 26.4. I know I don't need to do this in the calculator either. I'm just doing this for show. Divide by 10 gives us 2.64. And that is the variance of our numbers. Okay, on average, how much they vary. Now, to find this number, this standard deviation, that again kind of goes back to that bell curve looking thing we saw earlier, we need to do the square root of this number. So the square root of 2.64 is what we're after. So let's do the square root of that. Square root 2.64, and we've got our standard deviation. We'll go to about 2 decimal places here. About 1.62. In other words, if I go from my mean of 6.4 up or down 1.62 units, 68% of my data is within that distance from the mean. If you go out 2 of these, like 3.2 roughly, above and below the mean, that contains 95% of our data. And so these are different ways of looking at how clustered we're describing the spread of our data. Okay, let's try one more example. Pretty similar. So we've got, in this case, 9 data points, and there actually aren't any repeats, so putting them in order isn't going to do us any extra service. So I think here we're just going to go ahead and throw them in the order they're presented, 92, 96, etc. Okay, so you're going to write all these in, and then we're going to need to calculate the mean, which is the average. So this time there's only 9. We've got an extra line here we don't need. Okay, so let's find the mean or the average first. Okay, so we add them all up. That gives us 745. I'm going to press enter. And then I'm going to say take my answer and divide it by 9, since there was 9 pieces of data. So we add them all up, divide by 9, and my mean, we'll go to 1 decimal here, about 82.8. 82.8. Okay, and so we can fill that in all the way down, 82.8. Once we've done this, remember our next step is that we're going to find the difference between each data point and the mean, like we're going to subtract. And once we figure out the difference by subtracting, we're going to square that new number, 82.8. There we go. So we're going to need to do our subtraction, our equal sign, what's our difference, what's our square difference, etc. So I'll do just a couple of these. They're all going to be different, so I don't want to waste too much time on the screen here. You'll want these in your notes, so if you need to, you can pause. But let's say, at least 1 or 2 here. 85, our data piece, minus 82.8. Okay, gives us 2.2 for the difference, 2.2. And now we need to square that answer. So we can press answer squared. So it's taking 2.2 and squaring it. We get about 4.84. So about 4.84. Okay, just to reiterate, we'll do that again for our next data piece here. We're going to do 100 minus the mean of 82.8. Okay, that's 17.2. That's a big difference. So when we square this, we're going to get probably a pretty big number. Let's do answer squared. 295.84. 295.84. Okay, so we're going to continue doing this again, just like we did before. So I'm going to go ahead and fast forward a little bit. All right, so we found all of our differences. We've squared all of our differences. Now remember, to find the variance, we need to find the average of these squared difference numbers. So the ones in this column over here, we're going to find their average by adding them all up. We're going to put our answer where it says sum and divide it by how many there are, which is the count. In this case, 9 of those values. So let's add them all up, divide by 9, and we'll have our variance. Okay, adding them all up, I get about 2001.56. Okay, so let's write that in, 2001.56. Now to get our variance, we need to take that number, I guess I didn't write this step explicitly in the last one, but that's what we did, and divide it by 9. That's going to get us our variance. So let's take our answer, divide it by 9, and our variance is about 222.4, roughly. So 222.4. And to get our standard deviation, we just need to do the square root of the variance. So whatever the square root of that answer is, in fact, you can actually put it in square root of the previous answer. And our variance is about 14.91. 14.91 is our standard deviation, and there's our variance. So those are the two things that we're looking for. And again, this means that from my mean, my average of 82.8, if I go roughly 15 units left and right, so add 15 and subtract 15 from this, 68% of my data is within those 15 units from the mean in both directions. And if you doubled this number, which is approximately 30. So going up 30 or down 30 from this, from our mean, 95% of our data or more is encapsulated in there. Okay, so especially with when we have semi-normal distributions or nice smooth kind of bell curves where they're not really lopsided on one side like that. Anyway, that's what our formula way back here was telling us to do. All of these symbols, this is the population mean, or the mean of the population. That symbol's called mu. I'm not very good at drawing mu. It's like a U, but with a long end over here. Anyway, so that's called mu. That's the population of the mean. This is each data piece. So it's the data piece minus the mean. That's what we did. We squared that answer, right? And then we added them all up. And capital sigma here means to add. So you're adding all of them up from 1 to n, if there's n terms. Then, once we've added them all up, we divided by how many there were, divided by the count. That's what that was. And then we took the square root, gave us the standard deviation. Anyway, that's what this giant complicated formula does. It's exactly what we did here. Found the difference, we squared the difference, we added them all up, divided by 10, and then took the square root. Okay, so there's standard deviation. We now know these measures of spread: standard deviation, variance, range, and interquartile range. And the measures of center that we know so far are the main ones that we've heard of before, okay, which are mean, the average, median, the middle, and the mode, which is the most frequent. And remember, we said these two at least were a little more resistant to outliers, where the mean is affected a lot by outliers. Okay, anyway, so those are our measures of center. These are our measures of spread. We'll have a short quiz on this next class. Thanks, guys.